How can I go to that? Yeah, this is the one. Minimum falling path sum. So basically you have been given a 2D matrix, or you can say a grid, and then what you need to tell that what is the minimum sum that you can have for traversing the grid from topmost row till the bottommost row, right? You don't need to say that okay, you are starting from leftmost and you need to reach rightmost. It's not like that. You can start from any what say any element from the topmost row, and you can end on any element on the bottom row. So but you just need to tell the what is the minimum sum that you can take for this operation, right? For example, if this is your array, right? If this is this, and let's make it like a 2D grid. So what will do, I'll make another matrix, uh, right? Another 2D grid, and first row will be same as it is, because for first row there are no elements on the above a row than this. So this is a minimum sum that you need to come to this row. Now what is the minimum sum that you need to come at this position, like 6, okay? 6 element, this is like 2 plus 6, or you can come like 1 plus 6. So minimum is 1 plus 6, that is 7. So what is the minimum sum to reach this second row, second column, or first row, first column, if you say 0 indexing? So it's 1 plus 5, or 2 plus 5, or 3 plus 5. I would choose 1 plus 5, that's 6, because that's minimum, and 3 plus 4, or 1 plus 4, which is minimum. 1 plus 4, that's 5. So this is the minimum sum that you require to reach the second row elements. And for reaching 7, there are two ways. You can reach from 6, you can reach from 5. If you reach from 5, then 6 plus 7 is going to be 13. And here 8 you can reach from 6, 4, or 5. You will reach from 4, right? So 5 plus 8 is again 13. And then for 9 you can go from 5 to 9, or 4 to 9. You'll choose 4 to 9, right? That's 4 to 9 is again not 4, that was 5 over here, right? So 5 plus 9 versus 6 plus 9, you will choose 5 plus 9, that is 14. And let's make it more clear thoda sa. Now you need to see the last row and choose the minimum element in the last row. Minimum element is 13, so that's why your answer would be 13. So now let's just code it up. It's simple to implement a for loop. Int I is equal to 0, I less than n, I plus plus, and for int j equal to 0, n j plus plus. And then basically I did a mistake, like we should not start from 1, because for first row you don't need to do something, it's just same. And m is equal to your grid of I comma I minus 1 comma j, right? And m is equal to, if your j is less than or greater than 0, then only you can see this element, like you can see the top left diagonal. Otherwise if your j is 0, then the top left diagonal doesn't exist, because for 6 you don't have something like on the left of 2. So that's why you have to choose, say this condition, and then m is equal to minimum of m comma g of I minus 1 comma j plus j minus 1, right? Otherwise if your j is like uh, not, it's less than n minus 1, then only you can see for top right diagonal. For n minus 1 you cannot see for top right diagonal, right? So should be less than n minus 1, you can see the top right diagonal, that is m comma g of I minus 1 comma j plus 1. That is about it. And then you will say g of I comma j plus equal to m, right? And then you just need to see all the elements in the last row. Auto I n g of n minus 1. What you'll do, m is equal to minimum of m comma I, and you'll return m. M is equal to infinity or int max or 1e9. What is n? N is equal to g dot size. What is g? G is your matrix given. So change this to g. Let's run it and test it. It should work fine. Okay, accepted. Let's submit. Yeah, it's working, right? Pretty good efficiency. That's about it. Today's daily problem, that was minimum falling path sum. That's it. Okay, guys. Bye.